Say you're me and you're in physics and your teacher makes a ridiculous claim like parallel plates are easier than point charges because of blah 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 blah. So you decide to investigate by taking your own plates and hooking them up to a circuit. Plates like this are really capacitors. Traditionally there's a vacuum between them and the plates become charged by stopping the current in a circuit and storing up charge on either plate. We can treat each plate as covered in point charges when we investigate the electric forces it puts on charged objects between the plates. As long as an object is placed in the horizontal middle of the plate, it is presumed there is an equal number of charges to the left, right, front, and back of it. We can see that the horizontal components of the electric forces of each of these point charges cancel, and that the vertical components are equal. What's more, we can see that it doesn't matter where the object is vertically. As it moves farther from one of the plates, the magnitude of the force from each point on that plate is smaller, but the component of that magnitude which is vertical is bigger, resulting in an electric field which is always constant between the plates. Not only is this just very cool, it does make work with parallel plates a lot easier. The electric field, as long as you are not near the edges, is constant anywhere between the plates, and the voltage varies exactly linear with distance. Outside the plates, electric field and voltage follow the same rules they always have. The only three things you need to know in order to work out the electric field or voltage between the plates is two of the distance between the plates, the constant electric field, and the voltage difference between the plates. With this information, you can find out almost anything you need to know. A constant force field also makes it extremely easy to use kinematics with parallel plates. Say, for example, we have this tiny elephant with mass 0.05 kilograms who encounters a charged USS Enterprise flying away from a fight with an electric enemy. The collision leaves the elephant with a 0.003 coulomb charge and sends it flying towards two large parallel plates on Earth, which are 2 meters apart. If its velocity as it enters between the plates is 50 meters per second at a 45-degree angle from the horizontal, what will happen? The elephant is allergic to metal, so if it hits either one of those plates, it will die. Now we can use some of the forces to find what the vertical acceleration of the object will be. Because we defined up as positive, we will do the electric force, which is up, minus the force of gravity on the elephant, which is down. Once we see that the acceleration is positive, meaning that the elephant will accelerate up towards the top plate, we know that it will take a path somewhat like this. Because we know there is no horizontal acceleration acting on the elephant, and we know its initial velocity in the horizontal direction, we can tell how long it will take the elephant to travel the length of the plates, which is 4 meters, and use this time to see how long it will spend accelerating upwards. Too long, and he will be heading towards the top plate faster than he can clear it horizontally, which means that he's going to die. That's unfortunate for our friend the elephant, but at least we know how to work parallel plates problems.